Welcome to the Copperfield Electric Podcast.
Thanks for having me back.
Always good to have you here. So, I want you to think about something. Right now, behind the paint of your living room wall, there could be a miniature, completely invisible lightning bolt just firing off.
Yeah, it's a terrifying thought.
It really is. I mean, it's generating enough heat to turn the wooden studs inside your walls into actual charcoal, and your home's electrical security system is just completely blind to it.
Right, because we tend to rely on things we can see, like heavy deadbolts or security cameras, blinking smoke detectors. We want our safety to be visible.
Absolutely.
But we basically spend our entire lives surrounded by this massive high-energy infrastructure that's hidden entirely behind drywall.
Out of sight, out of mind.
Exactly. And it operates on these rules that most of us literally never think about until something goes wrong.
And that is exactly the mission of today's deep dive. We are going to explore those hidden hazards and really understand the massive technological leap required to stop them. Specifically, we're looking at the role of AFCI breakers in modern electrical panels.
Which is such a crucial topic right now.
It is, and to guide this, we are pulling from a really comprehensive June 2026 article on electrical fire prevention by Renee Hernandez.
Great piece.
Really detailed. And we're pairing that with some actual boots-on-the-ground operational notes from Copperfield Electric. They're a trusted, family-owned, 24-hour electrical service operating out of Orange County, California.
Which I love because it gives us this perfect blend, right?
Yeah.
We get the theoretical science of how electricity actually behaves.
Right.
And the practical reality of what happens when that science, collides with the aging hardware in our homes.
Yeah, exactly. So to you listening, whether you are maybe drawing up plans for a kitchen renovation, or you just bought this charming older home, or honestly, if you're just trying to figure out why your power occasionally trips.
This happens to everyone.
Right. This deep dive is going to map out the exact knowledge you need to keep your home safe and up to code. So let's just start with the physical hardware that most of us already have in our homes.
The standard breaker.
Yes. For decades, the standard circuit breaker has basically been the ultimate safety net. I mean, you plug in 3 space heaters, the breaker trips, and you just assume the system is doing its job.
Well, and it is, but that standard breaker operates on a very, very primitive mechanism.
Right.
It is essentially just a volume monitor. Inside that traditional breaker, there's a small strip made of 2 different metals.
Okay.
And when you draw too much electrical current, like with your 3 space heaters, the physical resistance creates ambient heat. And that heat causes the metal strip to literally bend.
Oh, wow. I didn't know it physically moved.
Yeah, it physically bends. And if it bends far enough, it just snaps the circuit open and cuts the power. So, it is designed perfectly to catch massive, uncontrolled surges or overloads.
But according to the Hernandez article, relying on that bending piece of metal leaves this massive blind spot. Because that standard breaker is completely oblivious to something called an arc fault.
Totally blind to it.
Let's think of that standard breaker as like a bouncer at a really crowded club. The bouncer's only job is to count the total number of people inside, right?
Right. Just checking capacity.
Exactly. If the capacity is 100 and person 101 tries to enter, the bouncer shuts the door. But that bouncer completely ignores the quiet arsonist sitting all alone in the corner booth just striking a match.
That is a perfect analogy.
That arsonist is the arc fault.
Yeah, and because the bouncer only counts the crowd, the arsonist is free to work totally undetected. The standard breaker looks at the total volume of electricity flowing through the wire and sees that it's perfectly fine. It's below the tripping point.
It's not an overload.
Right. The metal strip isn't heating up from a volume issue, so it doesn't bend. And the door just stays open.
So wait, if an arc fault is pulling a totally normal, permitted amount of power, how does it physically start generating so much heat without triggering the system's basic alarms?
Well, electricity always wants a continuous closed path. Always.
Okay.
And an arc fault happens when that path is somehow broken, and the electricity literally jumps across a tiny physical gap to keep moving.
It jumps.
It jumps through the air. And when it does that, it ionizes the gas particles in that tiny gap, creating a microscopic bridge of plasma.
Wait, hold on. Plasma. Like actual plasma inside the drywall of a living room.
Yeah, plasma that can reach thousands of degrees.
That's terrifying.
It is. It's this intense, concentrated, really smoldering heat. But here's the catch. Because the actual volume of current flowing across that plasma bridge hasn't increased beyond the breaker's limit, the breaker feels absolutely nothing.
So the wire looks perfectly fine to the panel.
Exactly. The panel thinks everything is great, while the surrounding insulation and, the wood frame of your house are slowly charring.
And the National Fire Protection Association data shows just how prevalent this actually is. I mean, they attribute roughly 42,000 home fires in the U.S. every single year to these arc faults.
42,000. It's a massive number.
It really is. And looking at the causes in the source material, we aren't talking about like catastrophic lightning strikes or power grid failures. The triggers are incredibly mundane.
Yeah, they are literally just the everyday realities of living in a house. I mean, it can be a loose connection where a wire meets a bedroom outlet.
Right.
Or damaged insulation. The Hernandez piece points out that just driving a simple nail into the wall to hang a heavy mirror.
Oh, I've done that.
We all have. But that nail can nick the protective casing of a wire behind the drywall, creating just enough of a gap for an arc to form.
Wow. The article also specifically calls out older homes, right? Particularly those built before 1975, because of the physical degradation of the wiring over time.
Yeah, the materials themselves fail. The polymers and plasticizers in that older insulation, they break down over decades of temperature fluctuations.
It just gets old.
It gets old and brittle. It's like an old rubber band you left in the sun, It cracks, and it exposes the bare copper wire underneath.
And this extends outside the walls too, doesn't it? Like pinched cords trapped under the leg of Eddie's sofa.
Oh, absolutely. Or those massive tangles of extension cords people use behind their entertainment centers, treating them like permanent wiring.
Guilty.
Right? But you step on them, you bend them, you create these micro fractures in the wire itself.
So, okay, if our standard metal bending bouncer is totally blind to this normal current plasma arc, the industry obviously had to invent an entirely different way to monitor electricity.
They did. They had to completely move away from simple mechanical physics and get into microcomputing.
Okay, so this is the arc fault circuit interrupter, the AFCI.
Exactly, the AFCI. So instead of just waiting for a piece of metal to get hot and bend, AFCI breakers actually contain a tiny computer chip, and it analyzes the actual waveform of the electricity thousands of times per second.
So it stops counting the total number of electrons, and it starts looking at the actual shape of how they flow.
That's a great way to put it. Yeah, because normal, safe electricity flows in a very smooth, predictable sine wave. It has a rhythm to it.
Right.
But a plasma arc creates a very specific, chaotic, high-frequency spike. It looks jagged.
Oh.
So the AFCI's microcomputer is constantly monitoring for that exact jagged signature. And the millisecond it detects the arcsing pattern, it digitally cuts the power.
Before a fire can start?
Long before the wood in the wall can even catch fire, yeah.
So whenever the acronym AFCI comes up, I feel like people inevitably confuse it with GFCI. You know, the outlets with the little test buttons we all have in our bathrooms?
Oh, all the time, yes.
Are they doing the same waveform analysis? Or is it something totally different?
Totally different. They protect against completely different physical hazards.
Okay, break that down for me.
So an AFCI is looking for those jagged plasma arcs to prevent electrical fires inside the wiring.
Tires, got it.
A GFCI, a ground fault circuit interrupter, is monitoring for leaking current to prevent electrical shock.
Oh, shock.
Yeah, it watches to see if the electricity is leaving its intended path and trying to find the ground, like if it travels through a puddle of water on the bathroom counter, or much worse, through a human being.
So to simplify, AFCI stops the fire in the walls, GFCI stops the shock near the water.
Exactly. But, the realities of a modern home mean those hazards often overlap.
Sure, like in a kitchen.
Right, kitchens or laundry rooms. Yeah. You have these high-draw appliances that can really stress the wiring, which creates fire risks, right next to sinks and washing machines, which creates shock risks.
So how do you handle both?
Electricians use dual-function AFCI GFCI breakers, so it's just one single device in the panel that handles both the waveform analysis for fires and the leak detection for shocks.
That makes sense. But let me push back on this a little bit, because if this AFCI microcomputer is constantly analyzing thousands of tiny changes in an electrical wave,
yeah,
won't it be hypersensitive? I mean, what happens when a massive appliance like my microwave suddenly kicks on? Won't it just give false alarms all the time?
This is actually a major point of frustration for a lot of homeowners. They think their brand new breaker is totally defective because it keeps tripping right when they're trying to heat up dinner.
Right, exactly.
Oh.
Like, is it a real hazard or is my microwave just acting up?
Well, the operational data from field electricians is really clear on this. The breaker is almost never broken.
Really?
It is just doing its job. Think about it. A microwave draws a massive surge of current right on startup.
Yeah, it pulls a ton of power all at once.
Exactly. And if you have a slightly loose wire connection somewhere in that specific kitchen circuit, that sudden massive surge of power stresses the loose connection.
Oh, I see.
It forces the electricity to jump that tiny gap for just a fraction of a second. So it creates a genuine microscopic arc.
Wow. So the AFCI doesn't trip just because the microwave is loud or pulling a lot of power.
No, it trips because the microwave surge exposed a real physical arcsing connection in the wall.
So when people are just resetting the breaker over and over, they're essentially just forcing the system to recreate the spark.
Exactly. It's a real warning sign, not a nuisance trip. It means you actually need a licensed electrician to come out and find that loose connection.
Not just a quick run to the hardware store to replace a quote-unquote faulty breaker.
Right. Do not do that.
Hmm.
And because this microcomputing technology is so effective at catching these hidden hazards, national building regulators have fundamentally rewritten the rules on how homes actually must be wired.
Yeah, let's talk about those rules. The National Electrical Code, the NEC, has really been steadily expanding the mandate for AFCI protection, haven't they?
They have aggressively.
Right, because under the 2023 NEC, specifically Section 210.12, this technology is now legally required on all 120-volt, 15 and 20-amp branch circuits in virtually every habitable room in a house.
It's basically everywhere now.
Bedrooms, living rooms, dining rooms, family rooms, finished basements. I read that even a hallway that is longer than 10 feet requires waveform analysis.
Yeah, the exemptions are getting very, very narrow.
Like what's exempt?
Well, bathrooms and garages are generally exempt from AFCI because they are strictly GFCI territory, right? Due to those immediate moisture and shock risks we talked about.
That makes sense.
And low voltage circuits are exempt too. Anything under 30 volts, like a doorbell transformer or a hardwired security keypad. But the way the code approaches kitchens now, that has created a massive shift.
You're talking about the dedicated refrigerator circuit.
Yes.
Because for a long time, the heavy draw of a refrigerator meant it was given a pass on AFCI requirements, right? So homeowners wouldn't have to worry about a nuisance trip spoiling hundreds of dollars of groceries while they were at work.
Exactly. But that exemption simply no longer exists under the 2023 NEC.
Wow.
Yeah, because refrigerators live in kitchens, and kitchens are now fully blanketed by the AFCI mandate. So your fridge circuit absolutely must be protected by that same microcomputer analysis.
And we should point out, this isn't just some abstract national guideline that nobody actually follows.
No, not at all.
Local jurisdictions, like the heavily populated areas of Southern California, they've adopted the 2022 California Electrical Code, which heavily mirrors these strict mandates.
And it is aggressively enforced in Orange County, let me tell you, whether it's new construction or just modified circuits.
Which introduces a scenario that the Hernandez article refers to as the renovation trap.
Oh, the renovation trap is real.
Walk me through it. Let's say you live in an older home, and you decide to open up the wall to add a beautiful new kitchen island. Or maybe you just extend a circuit to put some new outlets in a guest bedroom.
Right, pretty standard weekend remodel stuff.
But the code dictates that the entire extended circuit must now be brought up to modern AFCI standards, right?
Yes. You cannot just attach new wiring to the old standard and hide it behind the drywall. That is illegal now.
It's like taking the shiny body of a brand new Ferrari and just dropping it onto a rusted out chassis from 1950. Like, sure, you have gorgeous marble countertops and smart appliances, but the underlying safety infrastructure is dangerously obsolete. It just cannot handle the demands of modern electrical loads.
And the consequences of trying to bypass that upgrade are actually severe.
What happens?
Well, first off, if an inspector sees that an extended circuit lacks AFCI protection, they will immediately halt the renovation. You fail the inspection.
So a project is frozen.
Frozen. And worse, let's say you skip the permit process altogether, right? And then a hidden arc fault causes a fire 2 years later. The insurance company is definitely going to investigate.
Oh, of course.
And finding unpermitted, non-compliant electrical work is a really fast track to them completely voiding your homeowner's insurance policy.
Which is devastating.
It is. Plus, it creates a massive legal disclosure liability when you eventually try to sell the property.
So this strict code requirement really violently collides with the reality of millions of people living in older construction.
It forces a massive reckoning, yeah.
Because if your house was built in the 1990s and you suddenly need these advanced microcomputer breakers just to pass a basic kitchen inspection, the physical hardware of your old panel becomes the bottleneck.
Right. And the timeline is the key thing to understand here. The NEC didn't even start requiring AFCI protection in bedrooms until 2002.
2002, okay.
So if your home's electrical panel was installed before 2000, the engineers who built that box simply never conceptualized a breaker that needed a microcomputer inside it.
It didn't exist for them. So what does that physical incompatibility actually look like inside the panel?
It basically comes down to the bus bar.
The bus bar.
Yeah, the bus bar is essentially the solid metal spine running right down the center of your electrical panel.
Okay.
It's what distributes the raw power to all the individual breakers. But older bus bars were designed specifically for those small, simple, metal-bending standard breakers.
The bouncers.
The bouncers, exactly. They physically do not have the spatial configuration or even the required neutral wire connections to accommodate the much larger, highly complex AFCI devices.
Okay, but I know exactly what people listening to this are thinking, because I would honestly think the exact same thing.
What's that?
They don't want to deal with replacing a giant metal box on the side of their house. I mean, replacing an entire panel sounds like a massive, incredibly expensive headache.
Sure.
Can't I just go to the local hardware store, buy a modern AFCI breaker, and just kind of force it onto that old spine to pass my inspection and call it a day?
I get the temptation, I really do, but wedging incompatible technology into an old panel is one of the most dangerous things a homeowner can possibly do.
Really? Just for making it fit?
Yes, because it physically creates loose connections at the busbar itself, which, ironically, is exactly the kind of arcing fire hazard that the AFCI was invented to stop in the first place.
Wow. So you're creating the problem you're trying to prevent.
Exactly. A full panel upgrade isn't just an electrician trying to upsell you. It is literally the only physically safe way to bridge the gap between 20th century hardware and 21st century building codes.
And looking at the operational notes from Copperfield Electric really grounds this in reality. I mean, they operate 24 hours a day across this massive footprint in Orange County, Irvine, Anaheim, Santa Ana, Costa Mesa, Newport Beach, all the way down through Mission Viejo, Tustin, Huntington Beach, Orange, Fullerton.
It's a huge service area.
It is. And because of that, they're constantly dealing with the friction between aging coastal homes and these strict new building codes.
Right, because they handle everything from, original 1950s bungalows with super brittle wiring, all the way to brand new accessory dwelling units. So their field data provides a really clear benchmark for how to solve this safely.
Yeah, and according to their notes, the fear of a massive multi-day construction headache is actually totally outdated.
Oh, definitely.
A dedicated licensed team can completely tear out an incompatible 1990s panel, install a modern busbar system, integrate all the required AFCI and dual-function breakers, and literally restore your power in a single day.
One day. And honestly, doing it right the first time solves multiple infrastructure problems all at once.
How so?
Well, when you upgrade the panel to accommodate the safety computers, you also naturally expand the overall electrical capacity of the home.
Oh, right. You get more power.
Yeah. So that single-day upgrade basically clears the runway for installing, level 2 EV chargers or handling the load of energy-efficient LED lighting retrofits without completely stressing the system.
So the key takeaway from their approach is really that attempting these piecemeal Band-Aid fixes on an obsolete panel ultimately costs a homeowner far more in failed inspections, nuisance trips, and safety risks than just scheduling a single comprehensive professional upgrade.
Exactly. It shifts the mindset from just reacting to a tripped breaker to proactively building a really resilient, safe infrastructure for your home.
I love that. Well, we have covered a lot of ground in this deep dive.
We really have.
We started by looking at how a standard circuit breaker relies on primitive heat and bending metal, completely missing this silent, thousands of degrees plasma bridge of an arc fault.
Right, and we examined how AFCI technology fundamentally changed the game by analyzing the actual shape of the electrical wave, catching those chaotic spikes of a forming fire in mere milliseconds.
We also mapped out how the National Electrical Code has woven this technology into virtually every single room of your house. and how ignoring those rules during a remodel creates a really dangerous and expensive renovation trap.
And finally, we detailed the physical limitations of pre-2002 electrical panels, explaining why the metal spine of older boxes simply cannot handle modern safety devices without a full professional upgrade.
So if you are living in Southern California, you don't need to guess whether your home's infrastructure is hiding these blind spots. You can use the exact team we pulled today's operational insights from as your benchmark.
Which is incredibly helpful.
It really is. The licensed background check professionals at Copperfield Electric provide honest, competitive diagnostics, and they guarantee 100% satisfaction. They simply will not charge you for a problem that doesn't actually exist.
That's peace of mind right there.
It is. You can reach out to them directly for a free professional panel inspection by calling 626-622-9694, or you can email them at copperfieldltrc@gmail.com. Don't guess with your home safety. Let an expert decode what is really happening behind your drywall.
You know, understanding the physics of an arc fault leaves us with a really fascinating question to consider.
What's that?
Well, if electricity behaves almost like a living thing, constantly seeking a path, jumping microscopic gaps, and generating intense heat in the hidden spaces of our homes, how many other invisible systems in our daily lives are operating on totally outdated safety assumptions, just waiting for the right technology to decode their warning signs?
Wow, that is a brilliant thought to leave on. It completely changes the way you look at the walls around you.
It does.
Remember, standard breakers might count the crowd, but you need the microcomputer of an AFCI to spot the arsonist in the corner. Keep your infrastructure updated, and we will catch you on the next deep dive.